This video shows how to build a full-stack cloud app in minutes. Use GoGin for backend and Next.js for frontend. We will see the source code of framework, continuous integration and delivery in Kubernetes. Besides, we can also see log collection, service monitoring, and how to develop this application in VS Code remotely. All we need are 3 steps. Install Heighliner, prepare a Kubernetes cluster and spin up your app. Here is a Kubernetes cluster. It is a kind cluster running on the local machine. Nginx Ingress and Heighliner are ready in the cluster. Now, let's run HLN list stacks to check which one to be used. Let's spin up a new app by specifying gin next stack. After pressing enter, HLN downloads the stack automatically. Choose the default config. Input GitHub organization name or username. Input domain. After pressing enter, stack configures lots of components automatically. The process may take minutes to complete. In the meantime, we can learn more about the mechanism of stack. Stack consists of many modules, while modules are wrappers of third-party tools and platforms. By inputting the parameters by user, stack configures everything automatically. Stacks, modules and the core engine are totally open source, which means developers can customize their own stacks easily and share them conveniently. Back to the terminal, we can see the process is still running. In the meantime, we can check the GitHub repositories. 3 repositories have been created by the stack. Open them respectively. Here are the front-end service repositories with Next.js layout. Automatical building has been configured correctly. The backend repository also has the same configuration. In addition, Helm charts have been configured for GitOps with Argo CD. Back to the terminal, we can see the process has been completed. Here is the access URL of our application. Open it. Great! We can see the page provided by Next.js. Stack also provides some other helpful information. Enter the backend service URL. We can see the output from an API handled by backend service. We use Argo CD to manage the delivery following the GitOps rule. Log in first. Copy username and password from the terminal output. We can see there are 4 applications in Argo dashboard. Here we can see the application core we created before. Loki, localhost and Prometheus are also deployed as the essential components. We can see the details. Here is the object topology. Click here to see the traffic topology. All traffic will go through the ingress to the service and then to the pod. Let's check the application metrics. Prometheus and Grafana have been configured to monitor our system collaboratively. Stack has already provided the information. Just open it. Copy the username and password. Click here to check the dashboards. Select the Gin Application Metrics dashboard. And we can see many critical metric graphs of the backend service, such as request count, traffics, rates. Let's impose some pressure on our service. Prometheus will watch the metrics changes soon. Back to the dashboard, we can see PV has surged. This means our monitoring systems can quickly and accurately identify changes. So does the traffic. We can also check other useful information. Click here. You can see almost all the essential metrics. Here are the cluster resources metrics. Here is the situation with monitoring itself. Stack pre-configured these dashboards to provide an out-of-the-box experience for developers. Next, let's see the logging dashboards. Click here and switch the data source to Loki. Click here. And here to check the logs of pods. Select our backend pod. This bar hints at the pressure test we just did before. We can see all the logs with rich context and extra information. Scroll down to check older logs. Respawn time, IP, and other information at a glance. Enter expressions here for advanced queries. Next, let's see how to develop this app remotely in VS Code. Localhost can build a remote development environment with easy remote debug and live reload. First, open VS Code. Click Localhost Extension tab. Back to the terminal, we can see the username and password. After login, we can see the cluster, dev space. Currently, our application has not been deployed in this dev space. This means when we try to access the development environment link, we got 404. Let's deploy our application first. Choose the default version and the default configuration for Helm chart. The application has been deployed into our dev space. After the deployment, we can see it here. Check if the status is ready. A green tells the service is ready. Once we want to develop one of the services, all we need is right-click the name and click Remote Debug. We should tell localhost where the source code is. We can clone the source code from GitHub. After cloning, localhost opens the source code workspace automatically and switch the remote container to development mode. After mode switching, select Go Debug. We can see the source coding is being compiled. The green hammer icon tells us the service is being developed. Check the backend API again. 502 is got cause the source code is being compiled. We can check the source code while compiling. Here is the source code of the API. We can make a breakpoint here in the function once the debugger connected. Back to the browser. Refresh this page. Here we go, the program entered the debug breakpoint as expected. We can debug happily now. It is convenient to go next step, skip, evaluate variables, etc. Okay, let's continue. Now we can see the API output. Alright, we quickly experienced the function of stack. You might try other stacks following our document. Also, contribution is welcomed for both engine and stacks.